Carnival Cruise Lines is proud to present you with a very special tour. Have you wondered how the ship is piloted and controlled? Have you asked yourself, how does this thing actually go? Well, we'd like to take you behind the scenes of this technological masterpiece and show you the brain and the heartbeat of your Carnival Fun Ship. Your ship is 893 feet long, 116 feet wide, making it nearly as big as 3 football fields. She rises 16 decks over 234 feet from the keel to the top of the mast. That makes it taller than the Statue of Liberty. She is part of a class of cruise ships called megaliners because it is over 100,000 gross registered tons and is one of the largest passenger ships ever built. Gross registered tons is a measurement of the interior space, not the ship's actual weight as it might imply. It cruises from 10 to 20 knots and has a maximum speed of 23 knots, very fast for a ship of this type. A knot means 1 nautical mile per hour, roughly equal to 1.15 land miles per hour. Now, cruising about 20 miles an hour may not sound very fast, but when you do that continually for 24 hours, you can cover a lot of ground. Or water for that matter. Your ship can carry up to 3,400 guests and has a crew of over 1,070 ready to serve you. Before we start our tour, let's define a few nautical terms. If we look at a model of the ship and face the bow, we are looking at the forward part of the ship. Behind us is aft. To the left is port, and to the right is starboard. These terms are used to accurately define a place on the ship. You would never say another ship is on the left, but you would say another ship is on the port side. This helps to avoid unnecessary confusion. And now, off to the bridge. The bridge, or wheelhouse, is where the captain and his officers pilot and monitor the navigation and ship's operation. It is generally near the top of the forward section. This ship has a totally enclosed wheelhouse with wings that extend over the side for an unobstructed 355-degree view. At any one time, there are at least 4 people on duty on the bridge. This may not necessarily include the captain, but includes 2 senior officers and 2 quartermasters. The officers plot the course of the ship while the quartermasters will physically steer it. Let's take a look at the equipment and systems used to accurately and safely pilot a Carnival Fun Ship. In the center of the bridge is the main manual control for ship speed and thrusters. There's still an actual wheel for steering, but it's not as big as you might think. A computer translates movements and movement commands are relayed to the rudders. There are separate panels to control the speed of the main engines and thrusters. One panel controls the 2 main engines and propellers to move the ship fore and aft in the water. A second panel gives the pilot control of the 6 thrusters to move the ship from side to side during docking and turning maneuvers. On the far port and starboard side of the bridge are duplicate pilot stations for maneuvering in and out of port. From here, it is even possible to look down the side and see how close the ship is to the pier. In the forward and starboard sections of the bridge is a combination of traditional and cutting-edge navigational controls for charting the course of the ship and programming the autopilot. The ship is under control of the autopilot for about 80% of any voyage. The officer on duty uses paper charts to determine the ship's course, then enters it into the navigational computer. The NACOS uses 2 different global positioning systems and a Loran-C navigator system. The GPSs use 24 satellites in geostationary orbit around the Earth to determine the ship's position at all times. When the ship is 12 to 24 miles from the coast, radar is used to verify the position of the ship against the GPSs and Loran-C. Because of these double checks, the ship is never more than 50 meters off the computer's stated course. There are 3 radar systems on the bridge. 2 of them have a range of 48 nautical miles and can track up to 20 other vessels. The third system has a range of up to 96 nautical miles. The radars, like the GPS, are integrated directly into the NACOS system, giving it the capability of steering the vessel under autopilot control in 3 different ways: heading, course, or track. This way, the navigation computer keeps the ship on course regardless of winds and sea currents, and alerts the bridge crew when other vessels approach. The ship also has a course recorder, which keeps a 24-hour record of the ship's course and applied rudder. This works just like a black box in an airplane. It records every moment of the ship for later reference. The course recorder receives information from the 2 gyro compasses. These delicate instruments are kept isolated from all other systems on the bridge. They provide a constant reading of the ship's course and are checked against the other navigational equipment. Also on the starboard side is the Doppler speed log. This uses sonar to determine the depth of the ocean beneath the keel. Normally it is not used in open seas, but by regulation it has to be active when any ship enters or leaves port, or whenever in shallow water. And finally, on the starboard side of the bridge is the Napa computer. This system monitors all of the liquid storage tanks on board, including ballast, fresh, gray, and black water, plus fuel and oil. The level of these tanks are adjusted accordingly to maintain the balance of the ship and keep it sailing evenly through the water. On the port side of the bridge is the Global Maritime Distress and Safety System. This consists mainly of weatherfax, satellite communication, and radio telephone equipment. The main purpose of the GMDSS is to alert coastal stations and all ships in the vicinity of a vessel currently in distress. This reduces the vital search and rescue agency reaction times. These radios are also used for day-to-day communications between ship and land stations. The weather fax receiver prints information transmitted by more than 50 worldwide weather stations. There are 2 of these fax receivers, and the ship can also receive weather bulletins by email. Since this station contains all of the bridge's radio and telephone equipment, there is no need for a separate radio room. From here, the bridge can contact any place on the ship and call by satellite any place on land. The VHF radios are mainly used for short-distance communication, ship-to-ship or ship-to-shore. Next, there are indicator panels that give the status of the navigation lights and stabilizers. All vessels are equipped with navigation lights fitted on the upper decks, the funnel, mainmast, and stern. Red and green lights are fitted on the port and starboard sides respectively. All of these lights inform surrounding vessels of the ship's heading. Stabilizers are 5-meter-long retractable fins, which help steady the ship from rolling side to side in heavy sea conditions. They can help reduce roll by as much as 80%. There is also a draft meter showing how deep the bow and stern are in the water. These readings can also be taken visually for complete accuracy and are used to keep the ship properly balanced in the water. A Destiny-class ship generally sits only about 27 feet in the water, but is average for a vessel of this size. The portside aft panels have all the safety-related status and controls. There are panels that show the location and status of fire alarms, sprinklers, fire screen doors, fire dampers, and low-level lighting. The various detectors are monitored by a centralized computer system that will promptly and accurately indicate the area where an alarm is activated. If necessary, the computer will automatically proceed to close the fire screen doors and ventilation dampers in the area concerned. The watertight door panels show the status of all the ship's watertight doors. Watertight doors located below decks divide the ship into several separate watertight compartments. In the unlikely event of a hull breach below the waterline, flooding is minimized by completely sealing off any single compartment taking on water. This way, any flooding is minimized, and the ship remains stable on the water. And now, let's go below and take a look at the engine room. The engine room of this ship is dominated by massive diesel generators and 2 diesel propulsion motors to drive the huge propeller shafts. There are also systems for heating and cooling, creating fresh water, treating sewage and waste, as well as caring for the well-being of the guests. The diesel engines generate all the power necessary for propulsion and other services of the hotel department, such as air conditioning and lighting. There are 4 16-cylinder diesels that produce 11,200 kilowatts of power, and 2 12-cylinder diesel engines producing 8,400 kilowatts of power. At maximum capacity, the engine room is capable of producing a total of 62 megawatts of electricity. This is a lot of energy, capable of powering a small town. The propulsion motors each produce 20 megawatts of power and are regulated to turn the propeller shafts up to 150 revolutions per minute. RPM of the propellers is generally constant, and the speed of the ship is actually regulated by the orientation of the propellers. The propellers are designed so that the pitch of the blades can be changed by remote control. Altering the pitch of the blade controls the amount of water moved by the propellers, thus changing the speed of the ship. This can be done from either the bridge or the engine control room. In addition to supplying power to the drive engines, the diesel generators produce electricity for all other areas of the ship as well. Incinerators are used to create heat. Garbage is burned, and that heat is used to boil water and warm the air for public areas, should the ship ever need it. Some garbage is still offloaded in ports, but as technology advances, the need to offload garbage in ports is no longer necessary. Carnival ships do not discharge garbage while at sea. The evaporators provide fresh water from seawater. They create 630 tons of fresh water a day. And the total capacity of freshwater storage is over 1 million US gallons. Plenty of water for your next shower. Sewage treatment is all managed on board. Sewage is collected into 3 tanks and is chemically treated every day. Even though the water is mainly used for cooling and cleaning, it is biologically clean enough to drink. Another system important to the comfort and safety of the guests are the stabilizers. The stabilizers fold into the ship's hull from the bow aft. When extended, they act like paddles and steady the ship from rolling in moderately rough seas. The stabilizers are hydraulically controlled from rooms on each side of the ship. Finally, there are chillers to cool the air and water and provide cooling for food stores. Heat exchangers draw off waste heat and then distribute cooled water and air throughout the ship by way of pipes and vents. All of these systems are monitored and controlled in the engine control room. Here there is a giant mimic panel that shows the status of all the engine room systems. You can tell at a glance just what's going on with all the machinery. The engine control room also has direct controls for the propulsion engines, propellers, and thrusters. It is possible to pilot the ship from here with directions from the bridge. Remote control and monitoring of the generators and all other systems in the engine room is accomplished with the Dematic computer system. These 3 systems are linked together and everything is controlled by touch screen. The engineers simply touch the computer screen for the control they want to activate, and automatic servos take care of the rest. This is the ultimate evolution of engine control. Since the computer touchscreens are a remote control for the entire engine room, there is no need for engineers to spend all of their time around noisy, hot equipment. While the systems and engineering of this ship are state-of-the-art, no vacation would be complete without the dedication of the people on board ready to serve you. After all, a ship is only as good as her crew. We hope you've enjoyed this tour behind the scenes of the bridge and engine room of your Carnival Fun Ship, and wish you smooth sailing.